right, hi there. In this video, we're going to talk about what it means to be a function, and we're going to do a little bit of review of function notation, okay? Well, where we need to start is we need to begin by defining and reviewing what it means to be a function, okay? Well, a function is just a relationship between two quantities. That relationship could be an equation, it could be a graph, it could be a table, it could be ordered pairs, but it basically relates an x and a y quantity, okay? Well, a function is a special relation, okay? It's a relation in which one input, which we're going to end up calling the domain, has exactly one output, which we are going to call the range. Okay, and this is most commonly seen in math through equations, right? We plug one number in for x, we have one number that comes out. But functions are used in all different ways in real life. The best analogy that I think about with functions is I think about a pop machine. Okay, I think about a pop machine. So I want you to think of this idea that let's suppose that a pop machine costs $1, okay? So you put $1 into the pop machine, you hit the button, and one pop comes out. Now, let's suppose you go to the pop machine, you put $1 in, you hit the button, and nothing comes out. Well, we wouldn't say that the pop machine is functioning. Well, let's say you put $1 in, and you hit the button, and 2 drinks come out. Well, it might be your lucky day, but again, the pop machine is not functioning. It's only functioning if you put your money in, you hit the button, and one thing comes out. Okay, so what we're going to see here is common function notation is we might see something like f of x equals x plus 5. All right, well, we want to get comfortable with this notation. The f of x part right here is how we name a function. And so that could be g of x, h of x, k of x. There's all different letters we can use, but this part is how we name the equation, okay? This part is what we call the rule. And the rule of this function is basically you plug a value in for x, you add 5 to it, you get your output. So what I like to think of, since we're talking about this analogy of a pop machine, what we're going to do is we are going to find, okay, we're going to find f of -2, f of 0, f of 1, and we're going to find f of 2. Okay, well, what I like to do is I like to think about a machine, right? Kind of keeping with this analogy of a pop machine, is I want you to think about having one input in. Okay, so we've got our machine here. We put something in, and we've got one thing that comes out. Okay, and inside the function is our rule x plus 5. Now, what we're going to plug into the function are all of these numbers right here. These are going to be the inputs. Okay, we're going to input x equals -2. So what I'm going to do here is I'm going to keep track of this in a table. And so we're going to keep track of all our inputs right here, and the outputs are going to be the function values, which we can also think of as y values, okay? So we're going to input -2, we're going to input x equals 0, x equals 1, x equals 2. And that's what it's going to look like over here for our table. Now, let's come over to our function here, and let's suppose that we input right here x equals -2. So what we would do is we would plug -2 in for x, -2 plus 5, and we would output 3. And so the output are all of the y values. Okay, well, let's try this again. Let's try a different input. This time, let's input 0. So if we input x equals 0, then that means we plug 0 in for x, 0 plus 5, the output is 5. So when we input x equals 0, we output this function value 5, which is a y coordinate. All right, let's keep going with this. I purposely picked a function that was pretty easy. This time, if we input x equals 1, we input 1 for x, 1 plus 5, the output would be 6. And finally, if we input x equals 2, then we would plug 2 in, and this would be 2 plus 5, and our output would be 7. So you can see that it's really pretty easy to input and output into this function as we just plug in for x and we output this y value. So now that we have this table, we have all of these sets of inputs. Well, the input of a function is what we call the domain. Okay, and we would write this out by saying the domain, and I would list individually all these points that I plugged in using set notation. So the domain is the set of numbers of -2, 0, 1, and 2. Okay, well then we have all these values right here, which is the output. And the set of all output values is what we call the range. Okay, so I could also write the range using set notation, and we could write the range as the set 3, 5, 6, and 7. Okay, now what you're also going to see notation-wise is the domain are all of the set of x coordinates that get plugged in, and the range is all the set of y coordinates that come out. So what we can do with all of these points is we could also graph them. And what we could do is we could graph -2, +3. Okay, so when we say notation-wise, when we say that f of -2 is equal to 3, what this means is that the point -2, 3 is on the graph. When we go to plot f of 0 and say that it equals 5, again, what this means is that 0, 5 is on the graph. So we could plot 0, 5 right here. 1, 2, 3, 4, 5. All right, so we also know that f of 1 is equal to 6, so we can plot that, and we know that f of 2 is equal to 7. Well, this particular function, if we were to graph the whole thing, we actually see that this is what's called a linear function because all the points make a line. So it's a lot of different things that we've covered here. We've talked about input values, output values, domain and range, how to evaluate functions for different values of x, and how functions can be represented as graphs. Okay, so let's end with an example, and this is like some of the things that we did in class today. I pulled this example from an ACT test. Okay, so example 1, let's suppose given the function f of x equals 5 minus 3x. Okay, given the function f of x equals 5 minus 3x has domain, and we're going to use set notation, the domain is -1, 0, and 2. Okay, what is the range? All right, so take a second, hit the pause key if you need to write this down. So given the function, given the domain, -1, 0, and 2, what is the range? So we can do this in a couple of different ways. If we want, we could organize with the table where I input and the output here would be all the y values. So we could do it this way where we say that the input is -1, 0, and 2. We know that domain is always the set of x coordinates. Okay, and so that's one thing that we could do. We could also set this up like function notation, and we could find f of -1 equals, f of 0 equals, f of 2 equals. All right, so what would it look like if we took 5 minus 3x, and watch what I'm going to do here. I'm going to erase the x, and I'm going to replace the x with a parenthesis. What we're going to do over and over is we're going to take this function 5 minus 3, and we're going to keep changing what we plug in for x. So in this case, I'm going to plug in -1. And when we do this, we get 5, -3 times well, what happens is we get 5 minus 3 times -1 is -3. So this is going to be 5 plus 3, and the output is going to be 8. All right, let's try this again. 5 minus 3, and replace the parenthesis with the x with the parenthesis. So this time we're going to plug in 0. And this is going to be 5 minus 3 times 0, which is 0. So this time the output is equal to 5. Again, we're going to do this one more time with 2. 5 minus 3, and this time we're going to plug a 2 in for x, okay? So it's going to look like this. We're going to go 5 minus 3 times 2, which is 6, which is going to make negative 1. And so what we just found is that f of negative 1 is equal to 8. F of 0 is equal to 5, and f of 2 is equal to negative 1. So what we've learned here is all of these values right here, this is the domain, and all of these y values right here, 8, 5, and negative 1, this is the range. Okay, so again, all of these are the set of x's that get inputted into the function, okay? And all of these are the set of y's that output. All right, so with all of that, I just want to make sure I'm really going over this notation. To answer the question, it said, what is the range? So what we would say for an answer is the range is 8, 5, and negative 1. Okay, so that's what we're going to be getting into, is some different operations with functions and understanding what that notation means. All right, hopefully you got all this in your notebook. Go back, rewind through the video if there's anything you missed, and make sure you show me these examples in class. Thank you.